enormous and amazing search capabilities. And then Nanya took off. All right, so we'll start with, we have a new maintainer, which is cool. Kunrad? Hayden? Is that how you pronounce your last name?
Verheden.
Perfect. That's the Midwest American accent applied to your
not
Midwest American name. Kunrad has been with us for, I guess, a bit over 3 months and has just done great work in Tempo. He's been an agent. He's been doing operational stuff. He's been adding code. He's been adding features. He's been instrumental in search and participated with that in the hackathon. And he's even contributed to some of our upstream dependencies in OpenTelemetry. He's kind of just been everywhere. Everywhere he sees any kind of need, he jumps in and he gets some work done. It's been fantastic having him. So would you like to thank your friends and family, Kunrad?
No, I mean, I have a really good time working on Tempo. It's really fun. And yeah, I think we have a very good foundation right now. So I'm looking forward to everything we will be building on it. So search, and we're doing, all these reliability improvements. So yeah, it's really cool to be maintainer. I'm excited for the future.
Cool. Well deserved. Absolutely. It's been a lot of fun having you. And yeah, I think you're going to kill it with search with Marty and the rest of the team coming up in the next couple months. So very excited to see that. We also have an additional team member, Zach Leslie, master of egg crates. Would you like to introduce yourself?
Sure, yeah. My name is Zach, and I collect milk crates. This is true. So yeah, I've got a background in system administration, network engineering, SRE type work. And yeah, I've been a long time Grafana user, because if you're running systems and you want to know what's going on, so visualization and observability all really matters in that. And so yeah, I'm super excited to be here after, using Grafana for so long, and I love all the tool sets. So, and yeah, I'm just getting started with distributed tracing. So Tempo's going to be a lot of fun. I'm looking forward to it.
Awesome. Glad to have you here.
Yeah, thank you.
Cool. Also, okay, a couple blog posts. We had this really cool InfoWorld blog post. It's in that doc. I'll also just go ahead and slam it in the chat here. Oops, I just pasted the word InfoWorld into our chat and not the link, which is useless. Here we go. Oh no, I mixed up the links, didn't I? Oh no, I did.
Third time's a charm.
That's right. Okay, let's swap these real fast. Boink. It's all part of the show, gentlemen. All right. There we go. So this is the InfoWorld one. We'll talk about that one in a second. There's nothing really new in here, I don't think, for anyone who's used Tempo. It's really just kind of this high-level overview of what it can do and some of the other integrations with like exemplars and such. I really wanted to show it just to kind of show some of the growth Tempo has seen, some of the attention we're getting, out there in different publications. Tempo is really kind of catching on, and we're very excited to kind of see more and more companies use it and get more exposure like this. I think in particular, we've hit this kind of volume kind of niche that people love, and the like kind of cost of operations is much lower than other backends. And now we're looking to add those features through search that are really going to explode the, I think, the Tempo kind of universe. And then this link says Zach, and it has nothing to do with Zach Leslie. Instead, this is Zack Swanson, who's a community member who's very involved with Tempo, also Loki and other Grafana pieces, and he just wrote this blog post, and it's on our Grafana blog. I wanted to highlight it, just kind of just to say thanks to him and the work he's done, and also it's a cool post, and it's talking about how to run some of these things like Loki and Tempo in Fargate, and Fargate's a bit more ephemeral than other systems, and so he kind of goes through some of the issues he had and some of the things he had to do to fix that up. So, oh man, somebody put a much better description than I did in there. Thank you very much. But yeah, just kind of wanted to bring attention to some of these things that are going on in Tempo. Cool. V11. So we just cut V11. I'm sorry, we cut the first release candidate, RC0. Don't install it. Kunrad will tell you why in a second. But to go over some of the features, some of the new things that are coming up that we're excited about, that we think everyone will be able to use. First is this hedge request thing. I should probably be linking like PRs here. If anyone were capable of finding those PRs and bring them up, I'd appreciate it. Hedge requests basically will repeat a request, a GET request to the backend after so much time. So I think internally we have it set to 500 milliseconds or something. So if your request to your backend, GCS or S3 or whatever, exceeds 500 milliseconds, it can repeat that request. It'll do that once, so it'll only do it only do 2 requests at most. And really, this is just to get around kind of the long tail of the backend. So any backend, even something as stable as S3 or GCS, has a long tail, and you can easily set this kind of timeout, this hedge request timeout, to be at a point where you're only going to be repeating a very small percentage of your requests, like say 1%, and see amazing kind of an amazing impact on the P99 of tempo. So it costs almost nothing because you're just only repeating maybe 1% of all gets to your backend, and the kind of consequence of that is you just kill the P99 of tempo. I think we were seeing like 5 or 6 seconds P99, which is not great at all. We definitely want to get rid of it. Now we're down to like 2.5 seconds P99. So when tempo does execute a query, it can often, like a find by trace ID, it can often result in hundreds or thousands of requests to S3 because it's kind of doing this huge in parallel search across all your blocks. And so anytime you do 1,000 requests to something, you hit not the P99, right, but the P99.99, right? Because you've executed 1,000 requests. So you're seeing like the long tail of the backend service you're using. So this hedge request kind of helps deal with that problem. The second one, the tenant index, what's that?
I was just going to say there's like a slightly elevated number of requests to the backend because of that. It would be like whatever. If you set it to the P95, then 5% of your requests would be read, right? So, but it's like a small cost to pay to get the latency improvements.
Yep. Yeah, we haven't played with it much. I really just set it to 500 milliseconds for I don't know what reason. It was just a number in my head, I guess.
I think it was
and we haven't experimented with it at all, and it was just so impactful so immediately. I think we just kind of moved past it, but it'd be kind of fun to set it to 200 milliseconds or, try other values and just see what happens.
It's true.
But if you are using tempo, I think when you get 1.1, by default this is turned off. It's set to 0, which turns it off, this setting. So I'd recommend heavily kind of looking to tune that setting to reduce your latencies. The second one, the tenant index here, is to reduce calls to the backend. So right now, every compactor and querier has to know the state of the backend all the time for queriers to execute queries and for compactors to kind of reduce your blocks. And they are polling the backend by just listing every block over and over and over again. Well, I think once every 5 minutes is the default. So in smaller installations, this is probably not a big deal, but at the size that Grafana has reached, we're executing thousands of requests a second for no reason except to know the state of the backend. And that adds up over the course of a month in costs. And so this idea of a tenant index, only a small group of compactors are going to create basically a zipped JSON file. And the JSON file just has a list of every block. And then all of the other compactors and queries download that. So I tried to get some good documentation in here because it is a kind of a operational change that if you do operate tempo would be good to know about. So you kind of understand the way your system is working to help understand how to configure and also maybe what could go wrong, some of the failure modes. And I did my best to add some very solid documentation around that, but please kind of review that. And if you have any concerns or some of the documentation doesn't make sense, please file an issue. Please, you can bring it up on this call or mention it in the Slack, or just let us know, and we'd be glad to help clarify maybe what's going on and why we made the changes we did, and hopefully we can get you kind of confident in this switch. Cool. Ananya is going to tell us about what he did next.
Marty, did you want to say something?
Well, yeah, I guess about the tenant index. Did we call out, it's kind of beneficial for some workloads or installations where just the polling itself is become like a non-trivial cost, like it can become significant. And so this really helps drastically reduce just like the polling operations overall. Yes, I mean, not sure where that's come up, but it has before. Yeah.
It's come up, right. There's just like, there's definitely a flat cost, right, to polling on our Gits, but also people who have run, I haven't heard this from Tempo, but I've heard it from Cortex and Loki. People who are running it on-prem, and maybe they're running with something like Minio or any of the billion like on-prem S3 things you can run, S3 compatible things. They're having maybe issues with Tempo or one of these other applications overwhelming their backend. Like none of us can overwhelm S3, right? But if you stand up Minio, you can overwhelm that, right? Because you're operating that as well. So it's kind of also just to reduce the list calls and the Gits on maybe an on-prem backend.
Cool. So yeah, the next link change is about caching flexibility, and this is also about like sort of larger workloads. I would say it's not super relevant to smaller workloads where you can sort of fit all of the working set of Tempo in cache. So the working set of Tempo is the total size of all of the Bloom filters for all blocks in the backend, right? So for smaller installations, that's relatively smaller, but as the number of block list grows, like I think we had 22,000 blocks at some point in our backend, and then the size of the Bloom filters just sort of shoots up to 120, 150 gigs. And at that sort of level, it's not really advantageous to cache all of those Bloom filters. You may want to like pay a latency penalty and just sort of have a fraction of those Bloom filters in memory. So that's kind of what we implemented with this. It turns out that so for the lower levels in the compaction level, the blocks are actually, they have a lot of churn. So the compactors will quickly combine level 0 blocks together and move them higher up the level. So they disappear kind of quickly. And also super old blocks, that they're going to get deleted soon. So it's kind of advantageous to just have recent blocks that are higher up in the compaction level. And this PR sort of adds the ability to do that. It's kind of complex. And let me see if I can share a way in which we can figure out how we can choose which blocks we want to cache. Let me go ahead and share. What to do? Caching. So a page from our doc should be up. Yeah, see it. By the way, this PR, like I put it up and I went on PTO for a week, and Marty really worked on half of it, and it was merged before I came back. So that was awesome.
I was going to say for better or worse. Yeah.
It works. So we have this section on caching in our docs, and if you scroll all the way down over here, we have this cache size control, and this sort of talks about what we're trying to do here is to just store a fraction of the Bloom filters in cache, and for the rest of the blocks, Tempo will go and fetch it from the backend anyway. There'll be a slight latency cost, and because they're not in cache, obviously, right? And thanks, Joe. Nice doc. So we've added two sort of configuration options: the minimum compaction level and the max block age. So that sort of limits the blocks that will be cached. And if you sort of run this, okay, let me see if I can bring this image up. Let me share this down instead. So this is sort of a summary command that we added to our CLI, and it lays out how the blocks, the Bloom filters over the days as well as the compaction level. So you can see that there are like 20 odd Bloom filters which are 1 day old and at compaction level 0, and so on. So this sort of breaks down how the Bloom filters lay out over the days and compaction level. And you can see that the ones that are lower in the compaction level, we don't want to cache them. And the ones that are really old, we also don't want to cache them because they're going to get thrown out anyway. So really, we sort of want this quadrant of Bloom filters, which are recent as well as high up in the compaction level, because they're not going to churn, right? They're going to stay. And so to do that, we have these two parameters. You can just say cache a block only if it's above the level 2 or if it's not older than 48 hours. And I know this is like a little complex. So if you have any issues when you're using it, like feel free to just like open PRs or issues, and then we can improve on it. But this is something that we thought would work really well for a first pass. And it's already started showing some results. It's not very pronounced because we have like a lot of blocks at the moment, but it's still better than what we had without it. So yeah, I'll stop here.
Yeah, we would really like to hear from anyone who, what their experience is with caching, what amounts they're using, if these settings are helping. And maybe it really comes into play for larger installations. Like you mentioned, our environment had over 100 gigabytes of Bloom filters, and it's impractical to kind of cache all that. So yeah,
Okay.
yeah, we'd just like to hear any feedback.
Cool. Sure. So there's a lot of channels to reach us, like Slack, of course, this meeting, all kinds of different ways to get a hold of us, make an issue in the repo. If you do have feedback on some of these things we're adding, or certainly anything to help you operate it, let us know. We kind of have a scale, which is good because it lets us kind of find issues before other people. But it can also be bad because we just don't see some maybe of the issues of running this at low scale, and we're maybe fixing issues that we have. So we highly suggest or encourage everyone to help us know what issues you're running Tempo, so we can improve things and help you all get things going. Yeah. Next on the list is bad things, which we used an upside down exclamation point for because it felt like the opposite of an exclamation point. But I actually don't really know what an upside down exclamation point is for. Does anybody know that?
We use it in Spanish at the start. So you put the normal one at the end and that one at the start.
Oh man, it's like bracketed by both.
Yeah.
So at the beginning of the sentence says it's exciting. You don't have to wait till the end. That's pretty cool. All right, go ahead, Conrad.
Yeah. So while cutting the 101 release, we have been noticing a couple of issues with member lists in our largest clusters. So yeah, in this release, we have updated our Cortex dependency, which brings a lot of upgrades to, the ring, to member list, and to other stuff we use. But this also changed a bit how member list is configured, and yeah, we're thinking something might be causing trouble there, so we're still investigating that. But the things we're seeing right now is that compactors have trouble getting ready, and that member list is causing a lot of CPU. So if you, basically what we've been noticing, we're still investigating if you have to change the config somehow. So for now, our advice with the 101 release candidate is, you can try it, but might cause some issues. So, keep a good eye on that. We've been running it internally, and we're trying to track down the issues we're seeing. Yeah, and as similar to the previous part, if you have any issues running member list, just let us know, create an issue, reach out on the community Slack. We're constantly trying to improve it. So yeah.
Right, we cut that RC0, we deployed it, and we immediately noticed just much heavier like CPU and memory. We kind of tracked that down to some member list defaults changing. So I would recommend not installing that just yet, but we are on track to get 1.1 out. We'll just have some, big bug fixes and such. We'll be adding no more features until we kind of cut 1.1. So everything from now until 1.1 is going to be stability and, kind of rounding up whatever these issues are that we're seeing. And we are continually fighting member list. If anyone else is having issues with that, please let us know. We struggle sometimes to forget things. It sounds funny. Like you go, to the ingester ring or the compactor ring and click forget. And that's been, member list has generally been very good, but this one like haunting issue we can't get rid of. I'm kind of deep diving it now. So maybe we'll have a resolution, or maybe we'll tell you all to stop using member list and we'll remove it from defaults. I'm not sure. It's going to be one of those two directions probably. But I don't know. I hate to say I am close because I kind of think I'm close, but I don't know. It'd be nice to kind of finally put this one to bed for sure. Another one. Oh, sorry. Good.
I was just saying, you said you were close to removing member list altogether.
I'm not going to tell you what I'm close to. It's either deleting member list from our code base or finding the issue. Actually, it is one of those two things. I'm not sure which one it is yet. One more thing to add about 1.1 is we've deprecated 2 older block formats, which you probably don't even know about because Tempo kind of deals with these seamlessly. But there's some notes in the changelog for how to deal with this. If you install 1.1, there's nothing you need to do. But we're going to remove support for these in 1.2. And there's some details in that changelog about what you need to do, which is basically you need to upgrade to a version that will use the newest block version, which is v2, and kind of let all your older blocks fall off. But the changelog has some really good details added by Marty on how to kind of migrate forward. It's not really that you really have to do nothing except install a version of Tempo that understands both the v1 and the v2 blocks, wait for all v1 to go away, and then install 1.2. So just heads up that kind of change is occurring. And now service graphs are up, and unfortunately, I don't have a ton to say here because Mario is the primary kind of owner of that on our team, and he is currently on PTO. There was this PR that we dug up. Connor, I don't know if you have anything to add. You're welcome to say, I have nothing to add, Joe, since I'm totally putting you on the spot here, and we discussed this not at all beforehand. But if you know anything about service graphs, Connor's on the Grafana team proper. If you have anything to share, we'd appreciate it.
Nothing too specific to add. PR's in review right now, so looking to get that out soon. Excited to have it out.
Cool. Once Mario gets back, he's doing the work in the agent to kind of generate the metrics necessary to draw this graph. Connor and Andre are both working on the actual code to like display this in Grafana. So when he gets back, we'll probably maybe look to have a demo or look to kind of show a little bit more maybe next month at the community call in September. Cool. Finally, let's wrap this one up with Marty. Well, let's not wrap it up. If we have anything else, I don't want to say what's done. But Marty has some new info on search and some of the work we've done there.
Cool. Yeah. So in the last community call, we kind of walked through the timeline for what we see for Tempo search. And I think we did a live demo and we kind of showed off some of that. So we're not going to repeat that here. None of that has really changed. We just have some numbers from some internal benchmarking and performance testing and stability and things like that. So I'm going to go ahead and share that. But if you want to see all that kind of stuff, just go back through and look at the previous community call. Let's see. These are just like totally awful slides. Okay, cool. So everybody can see that. So what we did is we were testing out search in an internal environment that's kind of heavy. It's kind of like the one that we always are talking about with 100 gigs of Bloom filters and things like that. And so some stats about the environment. At the time, it was processing 1.5 million spans per second. And it's 40 ingesters and 20 distributors. So that's the right path. And that's kind of like what we're focusing on here. And the ingesters are keeping data for around 9 minutes. So that's kind of like the environment that we were working with. So for searching, so after letting it run and kind of like all the new data that's present on the ingesters has been indexed and things like that. And he's also search, meaning it's searching everything on the ingesters, was able to be completed in about 1.5 seconds. That was fairly consistent. And that means it was searching around 34 million traces or about 66 gigabytes of search data. And so each ingester, there were 40 of them. Each one was able to process kind of over 1 gigabyte per second or so per ingester. And so overall, the search performance we felt pretty good with. It was 45 gigabytes per second of search data per second, so leading to the 1.5 seconds for the exhaustive search. Now, not in exhaustive searches, so in exhaustive search we were doing by searching for tags that don't exist, so it was forced to search everything. But other searches were much faster if they were able to be completed and find enough results sooner than that. Cool. So that's kind of the performance. And again, that's just over around 9 minutes of data. So this is promising, but we want to search a lot more than the past 9 minutes of data. Resource usage. So there was a lot more overhead to turning this on, which we expected, but we have some numbers for that too. So storage-wise, it was around 1.5 gigabytes of extra disk storage per ingester for the additional search data. And so that's kind of like the 66 gigabytes distributed across the 40 ingesters. For on the right path, which is the distributor and the ingester, there was around a 25% increase in CPU, 30% in memory. And so the CPU is required for just processing the additional data, because as each trace comes in, kind of like that search metadata is extracted and built and built up and then saved. And then the memory actually comes from storing the live traces with their search data in memory. A lot of that, and then of course just other work going on. Cool. Any other things to cover about the performance? I do have another slide that I'll jump to.
Is that 25% CPU and 30% memory? Is that more on the distributors, the ingesters, or evenly, or split, or both, or what?
You know, I closed that tab, but I could pull it back up. That
I was
was
thinking,
overall. Yeah, so this was overall. I could pull that document back up, but that was overall across the entire environment. I mean, it was. Yeah, I'd have to get the better numbers about that.
Sure, it's no big deal. I was thinking it'd be more impact on the distributors because they do a lot of the work of like actually building that like index thing, right?
Yeah, so the ingesters do have a lot of work to do, because although the distributor extracts it initially and sends the bytes over to the ingester, that part's kind of efficient for the ingester, but there's still a lot of work to do. So if the trace is coming in multiple parts, those have to be unpacked and repacked together. And then after it's written to the wall, it then has to be flushed into another block. So there's a little bit more work to do there.
Okay.
Yeah.
Something that I want to do is right now, when we first release this in 1.2, it'll be in 1.2, right? Question mark? Probably.
Yeah, so that's the slide.
Probably.
I think so. Oh, my bad. Spoilers.
Oh, sure. Yeah, so I'll go ahead and touch on this. Oh, sorry. Like every time I do Google Slides full screen, it always messes me up. So that's why you'll just have to bear with me on this. So this is the same timeline that we showed off previously. So this hasn't changed. I'm just highlighting here kind of the section that we're talking about. So this is phase 1 of search. So Tempo will have an API. It will search the ingesters. And we will kind of have this experimental upcoming Grafana UI. So the Tempo pieces we're targeting for 1.2. So it's not the release we're talking about today in this. That's 1.1. It's 1.2 is the one after this. And then the Grafana version is to be determined. So we'll have more on that as we get there.
Cool. When this first is going to be released, it's going to be behind a feature flag. Is that right? Like you'll have to set a flag to turn it on?
Yeah, that's how we would start in Tempo. Yeah.
Okay. So I think longer term that will be dropped and it will be default, but I think we always want a flag to turn it off. So for people who want Tempo as just this high volume key value store backend, like with the kind of performance it has today, we want to always preserve that. We went over Marty went over some of those resource increases, which is of course expected, but for extremely high volume deployments, it's possible you would just prefer continuing to use your logs or your exemplars for discovery. So we want to kind of maintain that after this. So for a while, it'll probably be like a flag to turn it on, a feature flag, and then eventually we're flipped and it'll be a flag to turn it off if you prefer kind of, doing it the old fashioned way and having that level of performance that you have today. Because we do know some people, enjoy it for that kind of like extreme high volume backend, and this feature may not make sense for them. Cool. All right, I think that's roughly the end of our stuff. Questions? Any other agenda items or concerns or questions? Or if anybody wants to, tell a hilarious joke, that'd be fantastic. Be not very funny, people. A joke, that's right. What's his name? Richie likes using my name in terrible ways.
Yeah, it doesn't look like we have any additional agenda items from the community in the document either.
Cool. All right. All right. Well, everybody take care. Let's go ahead and call it if there's nothing else to discuss. And we will see you in about a month. Please reach out on our Slack channel. It's probably the best place to get real quick help. We also have community forum. Oh, there's a question here. 1 sec. We also have the community forum, which is a great resource, the Grafana forums to ask questions. And then the issue or the GitHub repo, we work very hard, every member of this team, to be very responsive on all of these different methods of contacting us. So please reach out on them if you're having issues. An overview of the Grafana Tempo deployment would be pretty helpful. CPU, memory storage, any config changes of note. Tanner, do you mean config changes in 1.1 or just kind of like an overview from base principles of Grafana's or Tempo's kind of architecture?
Okay, I'll turn on the video for this one.
Sure.
Yeah, so we're at Shopify. We're just rolling out Tempo. We're up to about, I've gotten it up to about 60 million spans per minute now. So it's getting pretty big. That's at a low sample rate. So we have a lot of spans. So our Tempo deployment is going to be pretty hefty. Basically, I'm just running into some issues around things like CPU throttle. Like there's no real good, like how much CPU do you give the distributors? How many replicas do you run? How much memory do you give them?
Sure.
Distributors seem pretty low on memory, so like I keep them fairly low. But the CPU seems to be very spiky, I've noticed on the distributors. And then same with ingesters. It's kind of I'm just going through like ground steps of getting things figured out. So an overview of an existing like the large deployment would be really helpful.
Sure. Let me just show you our.
Just throw me your Kubernetes figs. That'll be good. I'll go from there.
I'll just show you our internal dashboard. We can talk through it. This is our ops cluster. It's in a weird state right now because of some of the stuff we discussed with 1.1. So this is not entirely, I don't know, completely up to date. This cluster is taking 2 million spans per second at the moment. This dashboard is awful. It needs a lot of love, and we use it every day, or I do at least. Ingesters, we don't see spikiness on the ingesters really. I mean, unless it's below the Prometheus scrape interval, which is of course possible, right? It might be that we're just not seeing something that could be.
No, I think the spikiness was on the distributor CPU.
Yeah. I've seen in some cases, I haven't figured out why, but I've seen where I've just had a couple distributors sitting there not really doing anything. I've had that a couple of times as well.
I would look at your load balancing. Yeah, sorry, go ahead.
Oh yeah, no, that's a good one. I was going to mention also the ring to see if there's anything unhealthy in there.
The ring is typically good. I've had some issues where when I'm restarting my ingesters and it's replaying the wall, that can get a little funky sometimes. Like pods flapping because of that. I'm having pods flapping because of that right now.
So a couple versions back, we improved the ingester replay to not actually replay. Like it used to actually duplicate all the data into a new wall on startup. That was the actual replay, but there was, maybe it was in 1.0, we changed it to kind of just quickly rescan the wall files and replay a lot less.
I'm on a really recent version. I'm actually running
cool.
Like it was an R4 branch, I think. I needed the config expand end option. So I needed to run off the master for
that. How many ingesters do you have?
Right now, I just scaled it up, so I have 20 ingesters right now.
Okay.
It's been going up and down since this morning. I've been trying to get it back running again.
You're saying you're having ooms or panics?
So it seems to be some ingesters would stop running, or they would restart. And so I think I triggered this. We accidentally scaled down and lost 2 ingesters right off. And then it's kind of everything has struggled to come back a little bit because of that, it seems like. So then some get unready, and then it starts to kill some. And then those come back. They start doing the replay walls, so they're unready for like 5 minutes. So it's just kind of this like flood of things going on.
Sounds like your walls are quite big. Our replay is, I feel like seconds, like under 30 seconds. I would look at maybe your settings on cutting a block, like in terms of the size and age.
Okay.
And also, do we have compression on the wall on by default?
Oh yeah, I would turn that on. I think it's actually off by default. You should turn compression on the wall.
Okay, yeah, cool. That's good. That's good to know. I'll do that right away.
We use Snappy, and we went back and forth on it for a while, and we've been on Snappy now for months, and it's been very stable. So
right, so we use Z standard for the backend blocks and Snappy for the wall, I think is what we're saying. Yeah.
Yeah, I wonder if we should make that default. It is not. I kind of forgot about that setting. We've had it on Snappy for so long.
Yeah, right now I have about 70,000 blocks.
70,000, and you said it was
What?
60 million spans per minute, which is 1 million spans per second.
Right.
Yeah, the span rate is down right now because the ingestion's not quite right. That was what I peaked it at. That was yesterday.
70,000 blocks?
That's a lot of blocks.
Are you running the compactors?
Sorry, what was that question?
Hey, Joe, can you switch that component to the compactor?
Sure.
Or
I was going to
like
ask, like, do you have like a good number of compactors running?
Yeah, so this environment here is doing 2 million spans per second, and it has 18,000 blocks.
Okay, so
quite a bit different. Yeah, compaction. And Anya's right. I think compaction would be a good thing to look into, the settings there.
Okay, I'll take a look at that.
The compaction window in particular is a good one to reduce. So I think by default it's like an hour. And when you're creating a huge number of blocks, reducing that window like 5 minutes or something will allow a lot more compactors to participate very early on in the process at the level 0, which will reduce your block list quite a bit.
Okay.
So I'd look at dropping that.
Yeah. And also, what's your retention like? How many days are you keeping the data for?
I think it is 8 days right now.
Okay.
Let me take a look.
Yeah, I mean, I guess we don't have numbers that we've arrived at through like any sort of like formula, but I mean, maybe we could, do a better job with some guidance for different levels of scale. Like this environment, is in the 1 million spans per second. We could do guidance for something like that. And then maybe other loads like 100,000 or something.
How many compactors do you have, Tanner?
The compactors are pretty low right now. I think it's 5.
Yeah, we have 20, 40?
Yeah.
40.
40.
Yeah, it is a bottleneck of the system, the compactors, because it has to pull the entire block, which is a lot of data, right? Rebuild the blocks and send them back out. I don't know. I think at some point, we don't have plans in the immediate future to deal with that, but I think to get into like the 10s to 20s of millions of spans per second per cluster, we might start looking at changing the way we do compaction from this like full block compaction to something else. I don't know.
Okay, cool. Yeah, I can't get too much into our numbers for spans per second.
Sure.
We can, if we need to like do a test, we can get it very, very high here.
Sure. What's your backend? S3? GCS? Okay. I was really hoping you're on S3. I really want to hear of I want to know of a really high volume deployment on S3 to feel comfortable that it works the way we think it does. We've just never run on S3 at high volumes.
Also, I think like maybe in every community call we can just share our numbers on CPU memory ingestion and so on. That would be like a nice timeline. We can just go up, see the backlog of community calls, and not backlog, but like change log of community calls, and see how CPU memory is doing.
Right. That's not a bad idea. I kind of want to look at our other settings, see if I can pass anything else on. What are you using to hold your ring, Tanner?
It's memberless right now.
Do you have any issues with it? Can you
I
show us how to fix it, Tanner?
don't know if I have issues with it or not, to be honest, right now.
If
I've
you look
had-
at your compactor ring, I want to know if you have any unhealthy compactors in there. That's the big question.
I had one weird one where some old distributors were sticking around in the ring.
Yeah.
So
That's the bug.
like all of my deployments were gone, and I had like 4 or 5 unhealthy distributors.
Yeah, that is unfortunately the bug. And we are right now working hard to figure that out. And if I cannot figure it out in a couple of days, I think we're going to say, please use console from now on. Because it is plaguing us in multiple environments.
I'm just checking my compactor.
How long does a query take with 70,000 blocks?
Honestly, I haven't even queried it for a couple days now. Mostly just trying to get the system to be stable,
Sure.
and then we can start tweaking. Yeah, there are unhealthy compactors here.
Okay, it's the same bug. It's the same problem. All right, well, we'll talk about it in Slack some if I can figure this out. I'm really hopeful.
There's 8 unhealthy ones here.
That's also part of the reason you have a long block list, although just scaling up would be helpful. So with those compactors sitting there that aren't actually there, they own pieces of the ring, and the other compactors are basically ignoring entire sections of blocks they could be compacting. So that's part of that problem.
Okay, I just doing some prod editing here. So I scaled up our compactors.
Nice. We do 700 megs as our max block size. That's when it cuts to the wall. So I would also recommend looking at that.
That's the ingester the wall max block bytes.
Correct.
Right. The back end is much larger. So that would be another thing to look at too. Some of our examples are really small, like 1 gigabyte, and it's easy to run with those values and they don't work well for high loads.
Right.
Cool. I'm writing this down, so I'll take a look after.
Sure. Yeah, I think for sure the snappy wall would be a good thing to do. We also do this. Doink. Did we add this recently? Snappy compression between the distributors and the ingesters.
Should we make this default?
I don't know. I think we should probably, yeah. I think we should review our like homegrown config that we've slowly just worked on over time and make some choices about what to make default and whatnot.
Agree.
Because I think we have kind of settled on things that are quite good and we have never gone back and make those default. The snappy wall is one. This is one. I think there's another place where we can do compression, but I'm not seeing it. I'm just kind of glancing through our JSON.net right now. That's a good call. Here, I'll make a note to myself, to my future self. Cool. Awesome. Honestly, it's awesome to hear you having success at 1 million spans per second. 70,000 blocks is enormous, and we need to work to get that down, but we can help you do that. I would kind of expect it to just fail because of the queue size and the queryers, but give it a shot. Let us know what happens when you do that.
Cool. Yeah, I have a bunch of changes here to make now, so I'll have to roll this out.
Sure. Yeah, man. Reach out on Slack or whatever's convenient for you. As you kind of play with that over maybe the next couple of days or weeks, we'd be glad to get you in a more stable spot. And if you can't get your ingester stable, that's concerning, and we need to dig into that. So if you can't, please reach out and we can share logs or whatever, panic, stack traces or whatever you can get.
Okay, cool, will do. Yeah, we just started sending traffic, like the actual traffic on Monday. So we're just getting rolling here.
That's awesome. Cool. All right. Anything else, Tanner?
Nope. Well, that was all I had.
appreciate the feedback, man. And it's always good to hear about other people's installs. We use that to kind of balance our own experience. You know, we do have good experience running at scale, but to hear what other people are doing is always good, of course. Cool. All right. Well, on that note, unless there is any other questions, any other things in the doc, please add anything for the agenda there, question mark. Oh man, we got good notes here. Good job, Ananya. If there's not any other questions or that, we can kind of just go ahead and finish up. All right. Everybody take care. I will see you all next month, if not before. Tanner, I'll probably be hearing from him in the next couple hours. All right. Take care.
Bye, everybody.
Bye.
Bye. Thanks.
Bye.